turn to a very concrete problem that confronts us today. It is the pivotal nature of 5G technology and the threat arising from China's drive to dominate this field. 5G technology lies at the center of the technological and industrial world that is taking shape. In essence, communications networks are not just for communications anymore. They are evolving into the central nervous system of the next generation of Internet, the industrial Internet, and the next generation of the industrial systems that will depend on that infrastructure. China has built up a lead in 5G, capturing 40% of the global infrastructure market. And for the first time in history, the United States is not leading the next technological era. Now, much of the discussion on the dangers of allowing China to establish dominance in 5G have been focused on the immediate security concern of using communications networks that China can monitor and surveil. That is, in fact, a monumental danger, and for that reason alone, we should mobilize to surmount China's drive to dominate 5G. But the stakes are far higher than this. It has been estimated that the industrial Internet powered by 5G could generate new economic opportunities in the range of $23 trillion by 2025. If China establishes sole dominance over 5G, it will be able to dominate the opportunities arising from a stunning range of emerging technologies that will be dependent on and interwoven with the 5G platform. From a national security standpoint, if the industrial Internet becomes dependent on Chinese technology, China would have the ability to shut countries off from technology and equipment upon which their consumers and industry depend. The power the United States has today to use economic sanctions would pale by comparison to the unprecedented leverage we would be surrendering into the hands of China. It is important to understand how 5G will enable a revolution in industrial processes. Some Americans think that all we're talking about is analogous to the shift from 3G to 4G in our wireless networks. But we are talking about change that is far more fundamental than merely increasing download speeds for iTunes and websites and movies. The move from 3G to 4G meant moving from download speeds of about 1 megabit per second to around 20 megabits per second. And this increase made it possible to move the storage of data and some modest processing power off the devices and onto the cloud. But even this modest evolution of the wireless business spawned wide new fields of innovation, applications, and businesses. And because the United States was the country that developed 4G, we were the country that captured most of the economic opportunity that flowed from that technology. The jump to 5G is a quantum leap beyond this. We are now talking about multi-gigabyte per second peak rates for both download and upload. These fiber-like speeds, coupled with placing edge computing facilities closer to the users, means 5G is capable of extremely low latency, under 10 milliseconds. And with this capacity, the tiniest devices can have virtually instantaneous connectivity and access to infinite computing power. With these characteristics, 5G becomes a real-time, precise system of command and control. Devices of all kinds, some smart, some sensors collecting and transmitting data, some actuators carrying out remote commands, can be dispersed and embedded in business and industrial equipment across a wide array of businesses, such as transportation, energy, finance, healthcare, agriculture, heavy construction, and so forth. 5G provides the command and control function for managing all of these industrial processes. As the world of 5G unfolds, we will be seeing not just smart homes, smart thermostats, but smart farms, smart factories, smart heavy construction projects, smart transportation systems, and so forth, and a host of new emerging technologies, in addition to artificial intelligence, will become interwoven with and dependent on 5G and the industrial internet. For example, robotics, the Internet of Things, autonomous vehicles, 3D printing, nanotechnology, biotechnology, materials science, energy storage, and quantum computing. China has stolen a march and is now leading in 5G. 5G is an infrastructure business. It relies on a radio access network, RAN, facilities. China has two of the leading RAN infrastructure suppliers, Huawei and ZTE. Together, as I've said, they have already captured 40% of the market and are aggressively pursuing the balance. Huawei is now the leading supplier on every continent except North America. The United States does not have an equipment supplier. China's principal competitors are the Finnish firm Nokia with a 17% share and the Swedish firm Ericsson with a 14% share. The Chinese are using every lever of power to expand their 5G market share around the globe. It is estimated that the total market for 5G infrastructure is $76 billion. China is offering over $100 billion in incentives to finance customer purchases of its equipment. That means that China can offer its customers to build their 5G networks for no money down. And they have a sales force and technicians of 50,000 around the globe to push the acceptance of Huawei infrastructure. In an infrastructure business like 5G, and I say this as someone who spent 15 years in the telecommunications business, scale is critical. The business requires huge investments in R&D as well as very high capital costs. The larger a company's market share, the better it can afford these costs. Competitors facing a shrinking addressable market find it harder to sustain the levels of investment required to stay competitive. Chinese companies start with the advantage of the largest domestic market, giving them instant scale. And as they add this around the world, they will be able to invest more in their technology. The more China gains ground as a supplier of 5G infrastructure, the more it will also gain ground in all the constituent technologies that undergird 5G infrastructure. 5G rests on a stack of technologies including semiconductors, fiber optics, and rare earth and materials. China has moved to domesticate all of these elements, so it will not be dependent on foreign suppliers. Semiconductors provides a good example of the ripple effect of Chinese leadership in 5G. China now consumes over half of the world's semiconductors. China has now started to replace U.S. semiconductors with its own. Its scale in this field will permit it to make the investments needed to close the current quality gap. As China builds its scale in the semiconductor industry, it will place substantial pressure on alternative semiconductor suppliers. And of course, semiconductors are indispensable to a wide range of technology and industries apart from